In this video, I want to talk about using the Pythagorean identities, and I've actually copied all of the Pythagorean identities here on this particular video, so you'll kind of have them organized. There's really three primary identities. You have the cosine squared theta plus sine squared theta equals 1. You have secant squared theta equals 1 plus tangent squared. And cosecant squared theta equals 1 plus cotangent squared. And it's really, you only need one formula. You can get the others from the original, and the others are just algebraic manipulations of those three main formulas. I want to see if I can explain to you where they come from. You may not care, but it has that word Pythagorean in there. So hopefully that word makes you think of Pythagorean theorem that you probably learned in geometry, probably while you were in high school. Okay, and Pythagorean theorem has to do with the relationship between the legs and the hypotenuse of a right triangle. My triangle is going to be a little bit off. Okay, so you have a right triangle. The side opposite the right angle we call the hypotenuse. Typically, the straight sides we refer to as legs. And traditionally, we label those legs leg A and leg B, and we call the hypotenuse C. And so the Pythagorean theorem that you would have learned in geometry, we often read as A squared plus B squared equals C squared. Well, if we take that idea of the Pythagorean theorem and we kind of apply it or think about it with respect to the unit circle, which is on our coordinate grid, okay, and we think about that unit circle, and I'm going to draw one on there, so give me just a minute, okay, so you have your unit circle, a little lopsided, sorry about that, but you get the idea. Okay, and so if you think about drawing a triangle on this unit circle, okay, remember that the radius, because this is called the unit circle, the radius is 1. And in this case, that radius corresponds to my hypotenuse. So my radius is 1, and it's actually the hypotenuse. And so then you have the two straight sides, which would be our legs. And normally, again, we would call those A and B. But when we're thinking about it in terms of the coordinate grid, this is the horizontal is our X and the vertical is the Y. And so if we use the Pythagorean theorem there on that circle, that gives us the equation of the circle, x squared plus y squared equals 1. Well, what we've learned in trigonometry, see there's a progression here. What we've learned in trigonometry in relationship to the unit circle is that on the unit circle, the cosine of the angle, which we're calling theta, corresponds to the x coordinate, and the sine of the angle corresponds to the y coordinate. So then if I use that idea and do good old basic substitution, which is an algebra technique, into this formula for my circle, I have cosine squared of theta plus sine squared of theta equals 1, which is the very first Pythagorean identity. But it's all connected really back to a right triangle that has been superimposed onto the unit circle. I get the other two main Pythagorean identities if I take this first one and I divide, okay, and I'm going to do that for you so you can see it. I have sorry about that. 1 second. Let me get that erased. Okay, I have cosine squared theta plus sine squared theta equals 1. And I'm going to divide everything by cosine. Okay, so I'm going to divide, or by cosine squared. So I have cosine squared theta, cosine squared theta, cosine squared theta. And then if I simplify those, cosine squared over cosine squared is 1. Sine divided by cosine is the definition of tangent squared, equals 1 over cosine squared, which is the reciprocal, and that's the reciprocal of for secant. Okay, so that gets us the second one. Then the third one, again, if you go back to the first original identity, the cosine squared theta plus sine squared theta equals 1. And this time I'm going to divide everything by sine squared. So I'm going to divide each piece by sine squared. And I'll simplify that. So when I simplify it, we get cosine over sine is cotangent squared theta plus sine squared over sine squared is 1. 1 over sine squared, again, is the reciprocal identity, and that's going to be cosecant squared theta. Okay, so really all of them come from, and you don't have to know how to derive those, but again, if you want to know where they come from, they really all stem originally from the unit circle and the basic Pythagorean theorem. And so the way they have you use these is they have use these to find if you're given a specific value and then use it to find a second value. It's important to note what the original value is as well as in which quadrant you're going to ultimately be located. So, let's take a look at a couple of examples. It says, given that tangent of theta is 5/12 and theta is in quadrant 3, what is the cosine of theta? Okay, so I start off by thinking about this thing in terms of my unit circle or my graph and where I'm going to be. So it tells me that angle theta is in quadrant 3. So that tells me that somewhere over here in quadrant 3 is angle theta. And they also tell me that the tangent of theta is 5/12. And ultimately, I'm looking for cosine. So if I think about the different Pythagorean identities that I have, the one that involves tangent is secant squared equals 1 plus tangent squared. So that's the one I'm going to use. Secant squared theta equals 1 plus tangent squared theta. And you may think, well, Ms. Ralston, that doesn't involve cosine. Well, no, it doesn't, but we can get there by using this particular identity. So once I identify the formula or the identity that I need, then it becomes a substitution problem. So I have secant squared, which I do not know yet. Okay, so I have secant squared theta equals 1 plus tangent is 5/12, and I need to square that. And then I'm going to do the math. So I have secant squared theta equals 1 plus 5 times 5 is 25. 12 times 12 is 144. I need a common denominator, so I'm going to have 144 over 144 plus 25 over 144, and that's equal to secant squared theta. So then I'm going to do the addition. Okay, so I have secant squared theta is 169 over 144. But that's secant squared. Remember, I'm not looking for secant squared. I want plain old secant. Really, I'm looking for cosine, but I'm going to end up here with secant. So I'm going to square root both sides, and remember that when you take the square root of something, it could be positive or negative. So we're going to have to make a decision about whether it's positive or negative in just a minute. So I have the secant of theta is square root of 169 is 13. Square root of 144 is 12. Now, I'm in the third quadrant. My angle is in the third quadrant. In the third quadrant, the secant is negative. Okay, the secant is negative. So I found secant, but I'm looking for cosine. But I remember, or hopefully you remember, that the secant of theta is 1 over the cosine of theta. Or you can look at it the other way. Cosine of theta, which is what I really need, is the reciprocal of secant. Okay, so if I take the secant and find its reciprocal, okay, that's going to give me cosine. Reciprocal you find by flipping it over. So it's going to be negative 12/13. So the cosine of theta is negative 12/13. And again, it's negative because we're in quadrant 3. And in quadrant 3, remember, any ordered pair is going to have a negative x and a negative y, or in this case, a negative cosine and a negative sine. So that's one place where students get tripped up, is when they're looking at which sign, S-I-G-N, should be on their final answer. All right, let's look at another one. This one says, given that cotangent of theta is negative 12 over 5 and theta is in quadrant 2, what is sine theta? Okay, so here again, looking at this problem, I'm going to think about it in terms of my coordinate plane first. Okay, you don't necessarily have to do that first. It's just what kind of pops into my head first. Okay, so I'm going to think about it visually on my coordinate grid system. And it tells me that my angle is in quadrant 2. So somewhere over here in quadrant 2, I have angle theta. It also tells me that my cotangent is negative 12/5. I'm ultimately looking for sine. So I'm going to scroll back up for a minute so we can look at our identities. The identity that I have that involves cotangent is cosecant squared theta equals 1 plus cotangent squared. So that's the formula that I need. So I'm going to write it down. So make sure I get it right. Cosecant. Okay. So I'm going to scroll on down just a little bit. Cosecant squared theta is 1 plus cotangent squared theta. Okay, so again, once I've identified my identity, then it's a plug and chug. And here again, you may think, well, I'm looking for sine though, but you don't have an identity that directly gets you to sine. So we have to kind of do a workaround if you want to think about it from that perspective. So I have cosecant squared theta equals 1 plus cotangent is negative 12 over 5, and we're going to square it. So I have cosecant squared theta equals 1 plus negative 12 times negative 12 is positive 144. 5 times 5 is 25. To add those two numbers together, I have to have a common denominator. Sometimes the fractions are what trip students up terribly. So we have cosecant squared theta equals 25 over 25 plus 144 over 25. Cosecant squared theta is 169 over 25. And then I need to take the square root of both sides so that I can get just plain old cosecant. Okay, so I'm going to square root both sides. So I have square root. Again, you have to think about whether it's positive or negative. So I would have, I'm going to go up here to the side, cosecant of theta equals 13 over 5. And I got to remember, let me go back up here to my picture, that I'm in the second quadrant. In the second quadrant, the cosecant would be positive. Okay, the cosecant would be positive. So cosecant is positive 13 over 5. And then you have to remember, we're trying to get to sine ultimately. Remember that the sine of theta is 1 over the cosecant theta. It's the reciprocal identity. So if I use the reciprocal identity, the sine of theta, and I flip it over, I'm going to have 5/13. So the sine of theta is 5/13. And again, thinking about it, in the second quadrant, my sine would be positive. The y value is positive in the second quadrant. So that's not just extra information, guys. You got to pay attention into which quadrant you are locating. Okay? All right, let's try one more. All right, this one says, given that cosecant theta is square root 10 divided by 3, and theta is in quadrant 1, what is tangent theta? Okay, so again, I like to start out drawing my coordinate grid and getting a sense of where I am, get myself oriented. Okay, so it says we have angle theta in quadrant 1. So I'm somewhere in quadrant 1. And I'm told that the cosecant of theta is square root of 10 over 3. So again, I'm going to scroll back up to my formulas. And the formula that involves cosecant is cosecant squared equals 1 plus cotangent squared. Again, I'm not really looking for cotangent, but that's the only formula I have. So that's what I got to go with. Okay, so let's write our formula down. We have cosecant squared theta is 1 plus cotangent squared theta. Then I'm going to substitute what I know into that particular equation. So cosecant is square root 10 over 3 squared equals 1 whole plus cotangent squared theta. Okay, so square root of 10 times square root of 10 is 10, divided by 3 times 3 is 9, equals 1 whole, and that equals the cotangent of theta, 1 plus the cotangent of theta. I need to isolate cotangent, good old basic algebra. Okay, I'm going to isolate cotangent by subtracting 1 from either side. Okay, so I'm going to subtract 1, subtract 1. Okay, I'm going to go off over here to the side. 1 is the same thing as 9 over 9. So I have 10 ninths minus 1 ninth, which is positive 1 ninth, and that equals the cotangent squared of theta. I don't want cotangent squared, I want just plain old cotangent. So again, I'm going to take the square root of both sides, remembering it could be positive or negative. Square root of 1 is 1, square root of 9 is 3. That's going to equal the cotangent of theta. I'm in quadrant 1, the cotangent would be positive in quadrant 1, so I want positive 1/3 equals the cotangent. But I'm not looking for the cotangent, I'm looking for the tangent. And again, I have to remember that tangent of theta is the reciprocal of the cotangent. Okay, so again, I'm using the reciprocal identity. So the tangent of theta, we're going to flip it over, would be 3/1, or when you simplify, the tangent of theta is simply 3. And again, in the first quadrant, that value is going to be positive. Okay, so hopefully you found that helpful on how to use Pythagorean identities.